All right, guys. So the last topic we're going to talk about is dilution of solutions. Okay, so this is this idea of taking a concentrated, what we would call the stock solution, and then diluting it to make something more dilute. So for example, let's say that I had a 1.0 molar solution of sodium chloride. How would I use this to create a more dilute solution? So for example, something that was 0.05 molar NaCl. Okay, and in this specific example, you can see my concentrations cutting in half. That means I would take half of my solution, my stock solution, the 1 molar, and dilute it with another half of just water. Okay, so for example, 1 liter of 1 molar solution plus 1 liter of water, I would create now a half molar solution. All right, so this is what we're talking about. We're talking about going from the more concentrated stock solution to a dilute solution. And we can use this, we can use either a graduated cylinder would work, or which is one of the tools that you guys have in your at-home lab kits. The other thing that would work is a volumetric pipette. So we have these pipettes, or these transferring tools. You will see them in your future chemistry courses. But yeah, or a volumetric flask, as long as it's one of those. You know, the only thing about volumetric flasks is they only ever have one volume that you work with, right? So anyways, we could use either of those in order to create our more dilute solution. How we quantify how much stock solution we need is by using this equation: MC times VC equals MD times VD. So the C's are talking about your concentrated stock solution, and the D's refer to the dilute solution. M in these equations is molarity, and V is volume. Okay, so this is the molarity of the stock solution times the volume of the stock solution you use. So volume stock is equal to the molarity of the dilute solution, times the volume, the total volume of the dilute solution. Okay, so if any one of these, so I mean, this is equation MC times VC equals MD times VD. As long as we have 3 of these variables, we can find whichever the 4th one is that's missing. Okay, so let's do an example here. We're going to have a concentrated stock solution that's 12 molar hydrochloric acid. And we want to know what volume of that stock solution do we have to use in order to make 250 milliliters of 0.125 molar HCl, right? So we're going from a 12 molar solution to a 0.125 molar solution. So we're diluting our stock, okay? So let's look at our equation again. MC times VC equals MD times VD. So in this case, let's just run through and make sure what variables we got. We have the concentration of the stock solution of our more concentrated solution. So that's the MC. We're missing the volume. That's what we're going to solve for, because the other variables we have are the 250 mLs, that's of the dilute solution. And we know that we want our dilute solution to be 0.125 molar. So that gives me that variable there. So we're going to just rearrange this equation to solve for VC. So that would be VC equals MD times VD over MC. So then we can punch in our variables here. Again, the molarity of the dilute solution. So VC equals the molarity of the dilute solution is 0.125 molar. And the volume of the dilute solution is 250.0 mLs, divided by the concentration of our more concentrated solution, which is in this case 12 molar. So punch that into your calculator. 2.60416. That's what the calculator tells me. If I'm going to look at units, molarities canceled, and I'm left with mLs. So notice this would be the volume in terms of milliliters. And then lastly, for sig figs, I have 3, 4, and 3. So I'm going to take whichever one's fewer. So in this case, it's 3. So this would be 2.60 mLs. All right, so that means that you'd only need 2.6 milliliters of your 12 molar solution, and you would mix that to create 250 milliliters of dilute solution that has a concentration of 0.125 molar.